The question says we should find the integral using substitution method. Solution. Okay, so the first thing we do is to represent what we have in the roots with letter U. Okay, so we have 4x squared minus 1. Okay, so the UDS of this is 8x, okay, minus 1. How do I get it? I multiply this with 2, that is 8x. I subtract 1 from the power, so I have just x. So when you are differentiating a constant, you have it to be 0. So the UDS of this is 8x. Okay, but from here I can make ds the subject of the formula. So how do I do that? I swap the position, so I have du over 8x. So by doing this, I've made this the subject of the formula. So coming back here, I have the integral of 2x root, okay, 2x root 4x squared minus 1 dx equals the integral of 2x. So root, okay, 4x squared minus 1 is u. Okay, I've used u to replace that. Okay, my dx is now du over 8x. Okay, so here I can easily say x can go. I can easily say 2 and 8. 2 here is 1, 2 and 8 is 4. Okay, so now I can bring out 1 and 4 and say 1 over 4. Okay, the integral of, so here I can write u as u is power half is same with this time dot this. Okay, so I integrate this with respect to this. So when I do that, I have 1 over 4 times, so for this I have u to be, so u to be 1 over 2 plus half. So I divide this with 3 over 2. When I add it together, I have 3 over 2. So equals 1 over 4 times the value of my u in this case is 4x squared minus 1. Okay, so when I add this to this, I have 3 over 2. Okay, divided by, so here I have 3 over 2. So I'm dividing this with a fraction. And now, okay, I can simplify further. So I have a 1 over 4. Since it's a fraction, I'm dividing this with a fraction. Okay, so I have a times 2, okay, over 3. So I multiply everything I'm having here with this. So I have 4x squared minus 1. This is about 3 over 2. Okay, so here I have 1 times 2 to be 2 over, okay, 2 over 4 times 3 is 12. So I'm multiplying it with 4x squared minus 1 is about 3 over 2 plus my constant. Okay, so when I bring back my answer, so I can break this down as 1 over 6. So here I can write my answer as 4x squared minus 1. Okay, this is about 3 over 2 over 6. Okay, plus c. The question says evaluate using substitution method. So how do we go about this? We have solution. So do this using substitution method. We have to replace what we have here with a letter. Let's say letter u. Okay, so that is 2x is about 3 plus 3. Okay, and we differentiate this with respect to x. We have the u dx equals, when we differentiate this will multiply this. We have 6x. We subtract 1 from here. We have 2. So this is a constant. It turns to 0. Now we have to make the s the subject of the formula, which is the x. So what we do here is we change the position. So we have our du. So by the time this comes back, it remains 6s squared. Okay, so for the x, which is this. So we have the integral of s squared 2x raised to power 3 plus 3 raised to power 5 dx equals the integral. So I have my s squared. So since I've replaced everything here with u, So I have u raised to power 5, okay. Dx in this case is now du over 6x squared. So from here I can simplify. So this can go with this. So I have here the integral of u raised to power 5, okay, du. But do not forget, I still have my 6, so I have to bring it out. So I have 1 over 6, so I can integrate this. Okay, so when I'm doing that, I have 1 over 6. So to integrate this, I have times, I have 1 to the power, I divide by the power. So 6 over 6 times my constants, okay, sorry, plus my constants. So from here, I have 1 over 6 times the value of u, which is this, is 2x raised to power 3 plus 3 raised to power 6, okay, over 6, which is this, plus c. So my final answer is, when I multiply this with 1, I have 2x raised to power 3 plus 3, okay, raised to power 6 over 6 times 6 is 36 plus c, using substitution method. So here I have integral of 3x minus 7 raised to power 5 dx. So here I can assume letter u stand for 3x minus 7. So I'll differentiate this with respect to x. I have du dx equals, so when I differentiate this, okay, the power here is 1. I multiply this with 1, that is 3. So from 1 you subtract 1, that is 0. So this one has turned to 1. So differentiating this equals 3 because this is a constant, and when you are differentiating a constant, it is 0. So the u dx of this is 3, okay, but I want to make dx the subject of the formula. So what I will do is that I can interchange the position, okay. So when I do that, I have the u over 3, okay. So the integral of 3x minus 7 raised to power 5 dx equals the integral of, so in this case, I'll replace everything I have here with u. So I have u raised to power 5. So in the case of dx, which is du over 3, okay. So here I have a constant, I have 3. So I can decide to bring it out. So here I have 1 over 3, okay. Integral of, here I have u, which is u raised to power 5, okay, with respect to u. So from here now, I have 1 over 3. So when I integrate this, I have u raised to power 5 plus 1 over, which is 6. I divide by the power, okay, so I introduce a constant. So from here, I have 1 over 3. Okay, times, okay, my u in this case is 3x minus 7, okay, raised to power 6, everything over 6, plus the constant. So here, I don't have anything I can simplify. So from here, I'll say 1 times this is 3x minus 7 over 3 times 6 is 18, plus c. The question says, evaluate, we have integral of x, okay, divided by root s squared minus 5. So this is an integral function that involves substitution method. We go about this solution, okay. So the idea behind this is that we can represent every in the roots, okay, with the letter. So we have, let's say, letter u. So I have s squared minus 5. So I have to differentiate this u with respect to x. I have du dx equals, so when I'm differentiating, I multiply this with this power, I subtract 1 from the power. So here I have 2x. So differentiating the constant, that is 0. So from the u dx to the 2x, I want to make this dx the subject of the formula. So what I can do now is that I can just write my dx, okay, change the position, okay. So you have here du over 2x. So with this, by changing the position of this, we have made the s the subject of the formula, so it gives you this. Okay, so coming back here, so the integral of x over square root of square root of s squared minus 5 equals the integral of x over, so here I have square root of u. Okay, since my u is stated as s squared minus 5, so I replace it. Okay, so here I can say I have the integral of, I have here x, okay, over, so for u now, for this root u, I can write it as u raised to power half, is the same thing. Okay, so now when I have this, do not forget this comes with dx. Okay, so dx, so in this case I have my integral of x over u, okay, raised to power half times, so my dx in this case is this, which is du over 2x. Okay, so from here now I can look for what is common. I can say x is out, okay, they are common, and I can factor out the constants, okay, which is 1 in this case, and here I have 2, so I have here 1 over 2 integral of, here I'm having 1 over u raised to power half, okay, du. So to integrate this, I can write this as 1 over 2, okay, integral of u raised to power half minus half, which is as this, du. So I can integrate this with respect to u now. So I have here 1 over 2, so times, so this one is by saying, since I'm integrating with respect to u, so I add 1 to the power, I divide everything with the power, so I have minus half plus 1, okay, over minus half plus 1, okay. So here I have 1 over 2 times, so taking half from 1, instead of saying half, okay, divided by, so taking this from 1 as well, instead of saying half, okay, plus c. So here, from here, I have here 1 over 2, okay, so this 2 is multiplying what I'm having here, because this is a fraction at the denominator, so I have to reciprocate, so it's multiplying this one, so I have here 2 times half, okay, which is same as this, okay, times my u in this case, and I substitute back what u stand for, which is s squared, okay, s squared minus 5 raised to power half plus c. So this can easily go, okay, and I can as well divide this straight from here. This can easily go as well, okay, same thing. So I have u raised to power half, which is this, okay, plus c. So here I can write this as square root of s squared minus 5 plus c. So it's the same thing with this. Thank you very much.